Now I'm going to work this second example that I've set on this side of the board. Some of you are super high flyers, fast thinkers, that are really, really strong at this stuff already, see something that the rest of the class may not see here, which is really good. I'm glad that you see that. But we're going to work through this process either way. So we look to see if we have our common coefficient, and our x coefficients are 8 and 4, and our y coefficients are 10 and 5. So we do not have a common coefficient here. So we're going to need to get a common coefficient. The common coefficient between 8 and 4 would be 8. The common coefficient between 10 and 5 would be 10. So we need to multiply up to, x is up to 8 or y is up to 10. Let's go with the x's. They'll give us the path of least resistance because the signs are the same in both cases. If I had a different sign option, I would probably take it, but I don't. So I'm going to have to subtract on this one no matter what. So the x's are going to go to 8, and this top x is already 8, so we're going to leave him alone. 8x minus 10y equals 7. That won't always happen that you can leave one of the equations alone. If your coefficients are, say, 2 and 3, and you need to get them to 6, you're going to have to times the 2 coefficient by 3, and the 3 coefficient by 2. So don't think that one of them is always just left alone. The other one needs to be multiplied by 2 in order to make this 4 into an 8. So 4 times 2 is 8, x, 5 times 2 is 10, y, and 7 times 2 is 14. Now my super high flyers are really saying, I know what's going on here, and that's okay. I just want you to pause, keep that in the back of your heads. I'm sure you're right, but just hold on to it for a second. So now we're going to look at the coefficients that we made the same, which are the 8s. We're going to ask ourselves, are the signs the same? And they are, so same signs means subtract. We'll subtract the two equations from each other. 8x minus 8x gives us 0x, so the x's are gone. Negative 10y minus negative 10y also gives us 0y, so our y's are gone, and we end up with 7 minus 14, which is negative 7. So I have nothing over here, or 0, and negative 7 over there. One of the two classes, and I talked about this a little bit the other day because one of the students brought it up, but I wanted to really bring it forward just in case it does come up in today's worksheet. I don't think it'll be in today's worksheet, but it might show up on a test. So we want to be really careful that we understand what's going on here. What happens when we've eliminated both the x's and y's and not the coefficient part, not the constant part of the equation, is that we're looking at two lines that are parallel. And we talked about that before, when the x part's the same and the y part's the same, but the constant part is not the same, those lines are parallel, and this in fact has no solution. If the x parts were the same, the y parts were the same, and the constant was the same, then these two lines would be the same line, and they cross everywhere. This is just a quick lesson in remembering what we're looking for. We're looking for where do the lines intersect. Where do the lines intersect? So don't forget that. Alright, so now at this point in time, I want you to all either get a worksheet if you don't have one, or if you have your worksheet, I want you to work through problem number 1. I'm going to leave the answer to problem number 1 with the sub. I want each table team to have complete confirmation on what the answer to problem 1 is before they go and ask the sub. Once your entire table team has determined that that is in fact the answer to problem number 1 on your worksheet, then you can bring it to the sub. If the sub says that you have the answer to number 1 correct, then you can work out the rest of the worksheet. Please work the entire worksheet and have it ready to turn in for tomorrow. Thank you.